Pallab, Nidhi, yeah, okay. So
Hello, sir.
hmm, it has started now. Somebody has started.
Okay, sir.
Yeah, yeah. So what I was telling is that for scheduling as per the application requirements, so that there are multiple different applications which are running, and they all have different types of resource requests, resource requirements, right? So what are the parameters that govern the allocation or the mapping of these different resources to these multiple applications? So these parameters or these criteria, uh, these are dependent on these factors. What are these factors? Number one is the different applications. What are the requirements of resources from these different applications? This is the number one, right? It is quite logical. So what is your requirement, right? So every application, what is your requirement of the resources? This is quite fundamental and quite well understood. So resource requirement of applications is number one. Number two is that what are the different types of available CPU cores, the number of available CPU cores that are there, right? So this becomes other requirement, other parameter. And the third is that what is the amount of free space of memory that is available, right? Fourth is the storage space, how much of it is available. First one is memory, second one is storage, and the last one is the system state information. So the different systems, so what are the different states? State means like it is overall state, right? So based on the different states of these systems, so so the different resources are going to be allocated to them, right? So these are some of these different types of criteria which are used in order to determine how much and what sort of cloud resources are going to be given to these different applications that are requesting these resources. Okay. Next issue is um, there is something called the concept of abstraction. So here, you have heard about abstraction, this term abstraction in software engineering. You have heard about abstraction in programming, also object-oriented programming. You have learned about abstraction, right? So similarly, in cloud also, there is a concept of abstraction. It is quite parallel, very similar to what you have learned in terms of abstraction in the context of software engineering, object-oriented programming, etc. Here also it is very similar, but the context is different. Okay, so here we are talking about resource abstraction. So obviously, so the resources will have to be abstracted. And why do you want to abstract the resources? Because you want to make these resources available dynamically based on these different types of application requirements on an on-demand basis. So these resources will have to be abstracted, right? So there has to be some kind of a pointer, right, which will be pointing to these resources, physical resources, whenever a request is made. Okay, so the overall idea is that through the process of abstraction, you will be enabling these limited physical resources to be shared ubiquitously to these different applications or users based on their individual requests, right? So abstraction enables shared ubiquitous access to cloud resources. Second point is that, virtualization, right? Virtualization is basically nothing but, very similar to containerization, and containerization, microservices, etc. we spoke in one of the previous classes, right? So virtualization or containerization is basically key to resource abstraction in cloud computing, because everything. So the idea that the consumer feels like it has access to the ample resources, unlimited resources, etc. But physically, from a cloud service provider point of view, the resources are limited, right? So how this kind of um, you know kind of illusion to the consumers, how this kind of illusion is made possible, right? Through the concept of virtualization. So we need to understand what is this concept of virtualization in little bit more detail. Sorry, in more detail, we need to understand what is this concept of virtualization. Okay, because most of the concepts and the attractive features of cloud computing, this revolves around this concept of virtualization. So we need to understand what is this virtualization and how virtualization is enabled in order to provide cloud based resource access. So this virtualization uses a set of technologies to create virtual machine, virtual server, virtual storage, and virtual network. So basically, virtually, you can virtualize almost anything that you can think of. So we are going to talk about some of these different, resources which could be virtualized, and this you will see shortly that these set of resources, these could be varied, and you can have different types of virtualization made possible. Okay, so basically the same set of resources would be made available in a virtualized manner to multiple users at the same time, so that you can have concepts of virtual machine, creation of virtual machine, creation of virtual servers, virtual storage, virtual network. Virtually anything could be virtualized. Okay, so virtualization assigns a logical name to physical resources and provides a pointer when a request is made. So you have some resources there underneath, but through the process of abstraction, basically what happens is virtualization, what it does is that it will have some kind of a logical name or logical ID, which will be pointing to the actual physical resources whenever a request is made, on demand whenever there is a request made, right? And at other times, what is going to happen? The same resources are going to be made available to others. So basically the same set of resources based on the requirements, based on the requests that come through, and which could be varying throughout the day, the resources are made available to same resources are made available to multiple consumers at the same time or at different times, right? So this mapping that is made in virtualization through the help of these pointers, this mapping is dynamic. Why it is dynamic? Just think about some of the features of cloud computing that I said in one of the introductory classes. So you see that what happens in practice is that you have, let us say that you are a cloud user and you are using some resources, then you need to get more of those resources. So automatically you get those more resources, right? Whenever there is a demand, you get more resources. So how it is possible? So it is possible because dynamic provision of these resources, expansion and reduction of these resources, that is possible, and that is possible through the process of virtualization, right? So whenever there is more requirement of more resources, one gets more, and whenever this requirement reduces, these resources are released. Okay, so that is basically the concept of resource abstraction, which is made possible through the technology virtualization technology. So virtualization is very important. So virtualization, you see that this concept of virtualization became so important. So previously, when we were students at that time, cloud computing was not there. There was only concept of something called virtual terminals, right? So for example, virtual terminals could be created, and different people could be given different access to these virtual terminals, but actually the resources were the same, right? So same set of resources. So the concept of cloud computing was not there, but actually essentially whatever some of these technologies that are used in cloud computing, some of these were available in bits and pieces at that time as well. So virtual terminal is something that used to be there during our student days also, during my student days also, right? So the different types of virtualization, let us try to understand, and I have written a few over here, but I will be able to tell you a little bit more about the different other types of virtualization. Achha. So before I go through the different types of virtualization, you see that if you have noticed carefully, right, almost all of us have used virtualization in some form, even before we got into this issue of cloud computing. Some, something which has analogy to virtualization, we have been using it since long. So can someone give some examples of types of virtualization that you have been using? And mostly I think at least students of computer science or electronics, you should be able to tell. No one? Achha, let me tell you, because it may be hard for you to guess. I hope that can someone please confirm that I am audible to you?
Yes, sir.
Okay.
Yes, sir.
So what about hard disk partitioning? How many of you have partitioned your hard disk of your computer?
Yes, sir.
Yeah, yes, sir. I have.
Everybody has done, right?
Yes,
You
sir.
know what is hard disk partitioning, all of you?
Yes, sir.
So what do you
Yes,
do?
sir.
What do you do? You see that hard disk, I mean, I'm just trying to draw some analogy, right? It is not exactly the same. I'm just trying to draw some analogy. So you see that your hard disk, right? You could partition your hard disk in such a way that the same hard disk, physically, it is the same thing, right? But the same hard disk, different parts are being partitioned in such a way as if to the user it feels like it's a completely separate disk, right? Actually, it is not. Physically, it is not. It is the same hard disk, same resources, same storage. But on top, we get a feeling like it's a separate drive, right? Not exactly the same as virtualization, but I found that this is one of the, most, one of the most similar kind of concepts to virtualization. Not exactly, but very similar. Okay. So hard disk partitioning is something that I prefer to use as an example to motivate how virtualization, what virtualization is and how it is helpful. Okay. So let us go through these different types of virtualization. What are the different types of computing resources? Computing resources we have already seen today also, and in the last class, different types of computing resources like actual compute, right? Compute infrastructure. You also have storage resource. You have network, which also needs to be virtualized, right? So these are the different resources that could be virtualized, but these are not the only ones. There are many different types of other types of virtualization as well. For example, access virtualization, application virtualization. Like this, there is CPU virtualization, storage virtualization. There is also something called network virtualization, as I said, and there are many different other types of virtualization. For example, nowadays people are talking about data virtualization. And one of my students, Chandana Roy, who got a PhD, she proposed a new type of virtualization which is called decision virtualization. Okay, so that is called decision virtualization. So like this, actually people have come up with different types of virtualization. And I also have some of my previous students, for example, Subarna Chatterjee, Dr. Subarna Chatterjee, who completed her PhD with me. a couple of years back, who is currently at Harvard University. So she came up with the concept of sensor virtualization. So basically we work on sensors and sensor networks. So virtualization of the sensor resources is something that her PhD thesis was all about. So like this, people have come up with different types of virtualization. So let us try to understand some of these different types of virtualization that I have mentioned over here on this slide. Access virtualization, basically what it means is that the consumers, they can access the cloud resources from any location. So access is virtualized. So resources are fixed somewhere, it is there, but from any location in the world, these resources could be accessed from anywhere. So anywhere access to these cloud resources from any location is what is known as access virtualization. Application virtualization. So cloud basically has multiple application instances and directs the requests to one of the instances based on certain predefined criteria. Okay, then you have CPU virtualization, which is understood, right? So you'll be partitioning your computer into a set of virtual machines, and each of these virtual machines is going to work like individual machines, and they are going to be assigned a particular workload. So the CPU itself is mimicked in such a way that so through the process of virtualization, as if it is multiple computers that are working at the same time. Then you have the storage virtualization. This is very interesting, storage virtualization. So the data basically are stored in storage, and virtual storage is assigned by exhibiting the redundancy via replication. This basically reminds me about something called storage area networks. How many of you have heard about storage area networks? Storage area networks?
Sir, I have.
Very good. So you see that what happens, you see, so cloud basically gives you what? Cloud gives you as if you have, in terms of storage, you get unlimited access to storage, right? So essentially at the back end, what is happening is some kind of a storage area is formed. So you have different storages which are networked in such a way that, the data that are stored, these are basically stored in different locations, and these individual locations also share the storage across multiple different applications, right? So this is basically the storage virtualization. And another one that is not mentioned over here is called network virtualization. And I like this term network virtualization, particularly because my research area is actually computer networks, and I am fascinated. I mean, although I have not mentioned over here, but just for you to know. So network virtualization, basically, the whole idea is that the network resource has to be partitioned, logically broken down into different parts with unique IDs, so that it could be made available to individual users on demand. So this is basically network virtualization. So network virtualization means, like, for example, so whenever you talk about a channel in a network, right? So this channel itself can be thought of to have certain bandwidth, certain capacity, right? So it's like a pipe. This pipe has certain capacity, maximum capacity. So now think about how that pipe can be broken down into different logical channels, right? And whenever certain channels with certain capacity are required, these could be made available, and if there are more requests that come through, more channels will be made available. If so basically the entire bandwidth is broken down into multiple channels and made available on demand to the different users, right? So that is called network virtualization. So let me just give me a moment. let me pull something up for you. So basically, in network virtualization, so what happens is that this available bandwidth, as I was telling you, is split up, is broken down into different channels, and each of these channels is made separate and is distinguishable, and they could be either assigned individually to certain servers, certain devices, certain PCs, certain network equipments, or they could stay unassigned completely. And all of these is going to happen dynamically in real time based on the incoming requests. In real time, dynamically things are going to happen. So basically, through the concept of network virtualization, the true complexity of the network is disguised by separating it into parts that are easy to manage, much like what I was telling you in terms of management of files in a segmented hard drive, right? And storage virtualization, I already told you that using this technique, the user basically gets the ability to pool the hardware storage from several interconnected storage devices, which is essentially at the high level simulated as a single storage device that is managed from a single command console. And what is that command console? I'm going to talk about shortly, right? So this storage technique is often used in what I told you earlier, the storage area networks. So the storage is manipulated, right, in certain way in order to make the different activities of storage, for example, backing up of data, archiving of data, recovery of data, etc. So all of these are done, this kind of manipulation, in the cloud, right, through storage virtualization. Okay, so like this, actually, there are different other types of virtualization that are also, available. So virtualization leads to the creation of something called virtual machine, right? So virtual machine. So virtual machine has all the features of a physical machine, but actually it is not a physical machine. It is a software which mimics the properties of a physical machine. So whenever you get access to an instance of a virtual machine, actually it is simply a software that is running for you, dedicated to you, but physically it is, you get a feeling like it is a physical machine which is running for you, but actually it is a program that runs to give you that kind of exclusive access. Clear? So a system physical virtual machine or hardware virtual machine has their own resource allocation, input output with virtual driver, and address space in memory. So basically, it's a software, but actually it gives you a feeling that it's like a physical machine, like any other physical machine. So these virtual machines basically are created. There are several virtual machines that could be created on a host physical machine, and this host machine can run multiple virtual machines at the same time, each with separate operating system and applications. So you can have virtual machines, different virtual machines. So each of these virtual machines could be running different operating systems, multiple different types of applications, all at the same time. One virtual machine may be running Windows, another virtual machine could be running, let us say, something else, like that. So different virtual machines could be running different operating systems, applications, and so on and so forth, right? But actually it is a software. It's not a physical machine. So that is why it is called a virtual machine. Now these virtual machines are created. So you need some kind of a monitor for these virtual machines. So this monitor or the manager of these virtual machines is also called a hypervisor. Remember this term. Hypervisor is a very important concept. Virtualization and virtual machine monitor or hypervisor are some of the core concepts in cloud computing. So this hypervisor is basically nothing but a program. It is not like a normal kind of program, but a low level program, a system program kind of, right? Which helps in the creation and the management of these virtual machines. This hypervisor is the one which helps you to create these virtual machines and monitor these different virtual machines. The operating system running on the physical machine is known as the host operating system, and the operating system that is installed on the virtual machine is called the guest operating system. So guest operating system is a local one, right? So every virtual machine gets its own different guest operating system. But all of these virtual machines are running on the host operating system, which is actually the operating system that is running on the physical device, and that is called the host operating system. So host operating system and guest operating system. Host operating system on the actual physical device, the bare metal, basically the bare metal running this host operating system, and the guest operating system are basically individualized to these separate different virtual machines. There are two types of virtual machines. So this is actually, it's a little wrong over here. There are two types of virtual machine monitors. It should be monitor. Okay. So one is called the type 1 hypervisor and the second one is called type 2 hypervisor. So two types of not virtual machines but virtual machine monitors. So there is a word missing over here, monitors. So number 1 is type 1, the number 2 is type 2. So type 1 hypervisor looks like this. Look at the figure on the right hand side. Look at the figure on the right hand side. We have what? We have the type 1 hypervisor. So what do you see over here in type 1 hypervisor? You have a bare metal system hardware. Okay. And the hypervisor basically runs on this bare metal. Okay. So hypervisor runs on this bare metal system hardware. Okay. And so there is no host operating system in this kind of hypervisor. There is no host operating system. So this hypervisor runs directly on the hardware itself, system hardware itself. There is no operating system. There is no host operating system, as you can see over here, right? So some of these different examples, commercial examples of type 1 hypervisor are listed over here. Link Secure, RTS hypervisor, Oracle VM, like this. Actually, there are plenty of type 1 hypervisors that are available in the market. Okay. In contrast to this type 1 hypervisor, which, as I said, and is depicted in this figure, to run directly on this bare metal, the type 2 hypervisor has a host operating system on top of which it runs. So this hypervisor runs on a host operating system, and this host operating system belongs to the system hardware, right? So this hypervisor, the type 2 hypervisor, basically has an underneath host operating system which helps it to perform, right? And on top, as you can see, there are different guest operating systems like this running on top of these individual hypervisors. So this is called the type 2 hypervisor, and there are several different types of there are several different commercially available type 2 hypervisors. KVM, Microsoft Hyper 5, then you have Parallels desktop for Mac, and many others which are available in the market. So you have different types of type 2 hypervisors available in the market. So type 1 hypervisor runs on the bare metal. Type 2 hypervisor runs on the host operating system, and on top there are guest operating systems which are which function and are these basically help these individual virtual machines to work, right? So so this actually I will continue from next class, types of virtualization, but